Hello, great people. Welcome to this amazing health channel. Are you surprised to learn that certain foods might be fueling cancer cells? In this video, we'll reveal 6 unbelievable foods that you might be eating every day. Stay tuned to the end. Today, we'll examine the 6 acidic foods to limit in your diet. From the halls of prestigious institutions to the front lines of health advocacy, this advice brings together wisdom from across the globe. Featuring insights from Australia's Cancer Council, the National Library of Medicine in the USA, Healthline Media's team of experts, renowned voices like Dr. Colin Campbell and Barbara O'Neill. These trusted sources have united to offer you cutting-edge guidance on your health journey. Let's briefly review why maintaining a balanced pH is crucial for our health. Our blood typically has a pH between 7.35 and 7.4. However, when cellular pH drops to around 5.5, it creates an environment where various health issues can thrive, particularly yeasts, fungi, and cancer cells. Remember this key point: cancer thrives in acidic, low-oxygen, high-sugar environments. That's why many health professionals recommend an alkalizing diet, ways to increase oxygen in the body, and reducing sugar intake when supporting cancer patients. Now let's dive into these acid-forming foods. But first, what exactly makes a food acid-forming? These foods are typically high in certain minerals: phosphorus, sulfur, and chlorine. In the following segments, we'll explore 6 common acid-forming foods that you might want to consume in moderation for optimal health. By understanding both alkaline and acidic foods, you can make informed choices to support your body's natural defenses against various health challenges, including cancer. Number 1. Meat. When considering foods that are high in phosphorus, sulfur, and chlorine, meat often comes to mind. These elements are essential for many biological processes, but they also play a role in the health risks associated with high meat consumption. Dr. Colin Campbell, a renowned researcher, demonstrated the impact of meat on health through a groundbreaking study. He found that he could effectively switch cancer cells on and off in lab rats by varying the amounts of meat and dairy products they consumed. This finding underscores a crucial link between meat consumption and cancer development. Red meat and processed meats are some of the most common acidic foods in the Western diet. Red meat, in particular, is rich in protein and phosphorus, both of which contribute to increased acidity in the body. This heightened acidity has been associated with various health risks, including cancer. In 2007, a joint report by the World Cancer Research Fund and the American Institute for Cancer Research provided strong evidence supporting the connection between red and processed meat consumption and colorectal cancer. The report judged this evidence as convincing, solidifying the association between these meats and cancer risk. So, why are red and processed meats considered carcinogenic? It boils down to the chemicals they contain, both naturally occurring and those added during processing. For instance, red meat contains a compound called heme, which is broken down in the digestive system to form N-nitrosochemicals. These chemicals have been shown to damage the cells lining the bowel, increasing the risk of developing bowel cancer. Similarly, when processed meats are digested, they too produce these harmful N-nitrosochemicals. Processed meats often contain preservatives such as nitrites and nitrates, which, while useful for preserving meat, also contribute to the formation of these carcinogenic chemicals. But what exactly is red meat? Red meat refers to flesh from animals with a higher proportion of red muscle fibers than white muscle fibers. This includes meats like beef, pork, goat, and lamb. In the United States and other developed countries, red meat makes up a significant portion of daily meat consumption, with beef representing 58% of the red meat eaten in the U.S. Moreover, red meat consumption is on the rise in middle and low-income countries, such as China, where dietary patterns are shifting due to economic growth. The American Institute for Cancer Research offers a guideline for red meat consumption, recommending no more than 18 ounces of cooked red meat per week, emphasizing that less is better for overall health. On the other hand, processed meat is somewhat more complex to define. There isn't a universally accepted definition. but processed meats typically refer to those preserved by methods such as smoking, curing, salting, or the addition of chemical preservatives like sodium nitrite. Common examples include bacon, ham, salami, and pastrami. Some studies even classify certain ground meats as processed, depending on how they are prepared and preserved. While meat can be an essential source of nutrients, particularly protein and certain minerals, excessive consumption, especially of red and processed meats, poses significant health risks. These risks, particularly in relation to cancer, are well documented, and it is wise to limit intake to promote better overall health. Number 2. Wheat. Wheat is a staple ingredient in most of our diets, but there's an important issue lurking beneath its surface that we rarely consider. The wheat we consume today is not the same as the wheat from ancient times, and its evolution has had profound effects on our health. To understand the problem with modern wheat, we must first look back at its origins and the changes it has undergone. The original wheat, known as Einkorn or einkorn, was naturally created by God. This ancient strain had a fragile protein or gluten structure, making it much easier for our bodies to digest. Somewhere in history, possibly a few thousand years ago, Einkorn crossbred with wild field grass, resulting in a new variety called emmer wheat. Emmer still retained a relatively fragile gluten structure, but it was more resilient than einkorn. However, it was in the 1950s that a significant change occurred. Scientists began intensive crossbreeding efforts with emmer wheat to increase its yield, ultimately giving rise to the hybridized wheat we know today. This process fundamentally altered the gluten and protein structure, creating a much more complex and resistant form of gluten. Unlike the fragile gluten in ancient wheat, this new form is difficult for the human digestive system to break down. As a result, only individuals with what can be called a cast iron gut can easily digest it. For the rest of us, this explains the rise in gluten intolerance. By the 1990s, hybridized wheat had completely taken over the market. It became the primary ingredient in almost every type of processed food we consume. Pasta, pizza, biscuits, cakes, cookies, donuts, cereal, and bread are all made from this new wheat variety. Farmers favor this strain because it offers significantly higher yields, up to 6 times more grain per acre. This development was seen as a solution to global hunger, and it was pushed through without thorough safety studies. Unfortunately, the lack of rigorous testing has had consequences. The complex protein structure of hybridized wheat is now linked to gluten intolerance, a condition affecting millions of people today. The most common symptoms are brain fog and bloating, but the effects can be more far-reaching for some. As we continue to consume foods made from this wheat, it's essential to recognize how its hybridization has altered not just its nutritional value, but also how our bodies respond to it. Number 3. Refined sugar. While sugar itself has a neutral pH of 7, the way it interacts with the body during metabolism makes it highly acid-forming. When sugar is consumed, the liver metabolizes it, producing metabolic byproducts such as lactic acid and acetic acid. These byproducts significantly increase the body's acid load. As a result, sugar has earned its reputation as an acid-forming food. One of the reasons for this acidic effect is that sugar metabolism depletes essential alkaline minerals like calcium, magnesium, and potassium. These minerals are critical in buffering and neutralizing acids in the body, and their depletion weakens the body's ability to maintain a balanced pH. To make matters worse, consuming high amounts of sugar triggers insulin release, which can lead to the excretion of these alkaline minerals through urine. This further increases the body's acidity, contributing to an overall imbalance. Additionally, sugar plays a role in altering the gut microbiome. It encourages the growth of acid-producing bacteria in the digestive system, adding to the acid burden. The inflammation caused by sugar consumption also results in acidic byproducts, which exacerbate the acidic environment in the body. Though sugar appears neutral due to its pH value of 7, it wreaks havoc on the body's internal pH balance. This disruption not only increases the risk of disease, but also burdens the body with oxidative stress. This is particularly problematic because sugar consumption affects the balance of essential electrolytes like sodium and potassium, which are necessary for proper hydration and cell function. As a result, excessive sugar intake can interfere with the body's ability to absorb water, leading to further health issues. Another notable consequence of sugar consumption is its impact on calcium levels. When too much sugar is consumed, the body excretes calcium to help neutralize the acidic waste produced during sugar metabolism. This process depletes calcium reserves, potentially leading to weakened bones and teeth over time. Processed foods, which are typically high in refined sugar, crowd out healthier, alkaline-rich options like fruits and vegetables. Unlike processed carbohydrates and sugars, nature's foods provide a more subtle energy boost without causing the body's pH to spiral into an acidic state. Research has shown that individuals who consume large amounts of refined sugar tend to eat fewer health-promoting fruits and vegetables. This dietary imbalance not only leads to nutritional deficiencies, but also increases stress levels. The acidic environment created by consuming excess sugar triggers the release of cortisol, the body's primary stress hormone. This rise in cortisol levels leads to anxiety, chronic inflammation, and long-term stress. In addition, the waste products generated by sugar consumption contribute to oxidative stress and an overproduction of free radicals, which can damage cells and tissues. Chronic inflammation is another serious consequence of high sugar consumption. Research has shown that even a single can of fizzy juice containing 40 grams of added sugar can increase inflammatory markers such as insulin resistance and LDL cholesterol. This is particularly concerning because insulin resistance is a precursor to type 2 diabetes, while elevated LDL cholesterol is associated with an increased risk of heart disease. In addition, excess sugar consumption raises levels of uric acid, which further contributes to inflammation and insulin resistance. Interestingly, people who consume milk, water, or diet beverages do not experience this rise in uric acid, underscoring the harmful effects of sugar-laden drinks. Before we continue, don't forget to give this video a thumbs up and subscribe for more great content. Have you done so? Great, let's continue with the rest. Number 4. Caffeine foods. Caffeine is a common stimulant found in many foods and beverages, and while it offers a temporary boost of energy, it is important to be aware of its long-term effects on the body. Caffeine, along with other acidic foods, has an acid-forming effect. When consumed in excess, it can disrupt the body's delicate pH balance, putting stress on its natural regulating systems. A diet high in acidic foods like caffeine, animal proteins, and processed products forces the body to work harder to maintain pH neutrality. This extra effort can deplete essential alkaline minerals such as sodium, potassium, magnesium, and calcium, which play a vital role in keeping the body healthy. When the body's reserves of these minerals are depleted, it becomes more susceptible to chronic and degenerative diseases. This is why moderation is key when consuming caffeine and other acidic foods. Furthermore, caffeine is often paired with sugar, which exacerbates the negative impact. A prime example is Coca-Cola, a popular drink that combines both caffeine and sugar. Its acidic nature, coupled with a heavy dose of sugar, can have toxic effects on the body. In fact, Coca-Cola's pH level sits around 2.6, a dangerously acidic level, making it a drink best consumed sparingly. Caffeine doesn't just hide in coffee and tea. It's also present in chocolate, and often added to a surprising variety of snacks like gum, jelly beans, waffles, and even sunflower seeds. This means we might be consuming more caffeine than we realize, simply through our everyday snacking habits. To manage caffeine intake, the FDA advises healthy adults to limit consumption to no more than 400 milligrams per day, which is roughly equivalent to 4 or 5 cups of coffee. At this level, negative effects are not typically associated with caffeine consumption. However, when it comes to children and teenagers, the American Academy of Pediatrics takes a more cautious stance. They discourage the consumption of caffeine and other stimulants by young people, as their developing bodies are more sensitive to the potential risks. While caffeine can provide a quick energy boost, it's essential to monitor and moderate how much we consume. Balancing acidic foods like caffeine with alkaline-rich foods can help support overall health and prevent the body from being overwhelmed by acid-forming substances. Number 5. Alcohol. Alcohol, although not a food, has a profound impact on the body's internal environment. When alcohol is consumed, it undergoes a breakdown process in the liver, converting into a compound known as acetaldehyde. This compound is a neurotoxin, which means it is harmful to the nervous system, particularly the brain. Neurotoxins can interfere with normal brain function, leading to various negative effects, including memory loss, cognitive impairment, and other serious health concerns. Essentially, consuming alcohol introduces a brain killer into your system. Beyond its impact on the brain, alcohol also contributes to the formation of an acidic environment within the body. The body's pH level is crucial for maintaining overall health and well-being, and an overly acidic state can lead to various health issues, including fatigue, weakened immunity, and an increased risk of chronic diseases. While it may sound alarming, the good news is that you don't have to completely eliminate acid-forming substances like alcohol from your diet. Maintaining a healthy balance is key. To achieve an optimal pH level of around 6.5, it is recommended that you consume around 20% acid-forming foods, such as alcohol, while the majority of your diet, 70 to 80%, should consist of alkaline-forming foods like fruits, vegetables, and certain grains. This balance allows your body to neutralize the acidic effects of alcohol, ensuring you can enjoy occasional indulgences without compromising your health. The goal is not to live in deprivation, but to be mindful of the impact of what you consume, ensuring that your body stays in a state of equilibrium. Number 6. Cheese. Cheese is a beloved food around the world, but there's more to it than just its rich flavors and textures. Among the varieties, aged cheeses like blue vein cheese stand out for their distinct characteristics. So, what exactly is the blue in blue vein cheese? Interestingly, the blue in this type of cheese is quite mild in flavor, despite its bold appearance. The veins of blue mold that run through the cheese may look intimidating, but they often impart a smooth, nuanced taste that enhances the overall experience. While aged cheeses like blue vein cheese fall under the acidic category due to their pH, there are cheeses that don't. Fresh cheeses, such as cottage cheese and ricotta, tend to have a higher pH, often around 7, placing them closer to neutral on the pH scale. However, it's worth noting that the quality of fresh cheeses can sometimes be compromised if they come from cows that are not properly fed or are treated with chemicals. This can impact their overall nutritional value and health benefits. In general, dairy products are classified as acid-forming foods. This classification is based on the concept of potential renal acid load (PRAL), which measures the acid or alkaline effect that foods have on the body after digestion and metabolism. Foods high in protein and phosphorus, such as dairy products, tend to be more acid-forming. As these foods are broken down by the body, they produce acidic compounds that must be neutralized or excreted by the kidneys, placing a higher acid load on these vital organs. For example, common dairy products can be categorized by their acid-forming potential. Milk, slightly acid-forming. Cheese, moderately to strongly acid-forming, depending on the type. Yogurt, slightly acid-forming. However, it's essential to understand that the acid-forming or alkaline-forming properties of food don't necessarily reflect their overall health benefits or risks. A balanced diet that includes both acid-forming and alkaline-forming foods is typically recommended for optimal health. Cheese, for instance, despite being acid-forming, is a good source of calcium, protein, and other essential nutrients. Cheese can also be made from the milk of various animals, such as cows, goats, and sheep. The pH level of cheese, which determines its acidity or alkalinity, varies depending on the type of cheese and how long it has been aged. Generally, cheese tends to be on the acidic side of the pH scale, especially aged varieties. But this acidity is part of what gives cheese its distinctive flavors and textures, making it a staple in many diets worldwide. Thank you for watching. If you found this video helpful, hit that subscribe button and tap the notification bell for more content. Feeling inspired? Great! Your journey to better health doesn't end here. Check out our next video to keep that momentum going. Remember, every healthy choice counts.